Okay, then we have also here the calculated glomerular filtration rate. So, pag sinabing calculated glomerular filtration rate, so we try to use here the formula just to predict us then to identify the glomerular filtration rate without collecting the 24-hour urine collection. Yung kanina na standard formula na U times V over P, again, you are requiring the patients to collect here the 24-hour urine collection. So, medyo mahirap yun. But this one, wala na siyang urine collection at 24 hours. What you are needing here are the following variables. Just be needing here the plasma lang, blood ni patient lang with its creatinine concentration. We're needing the age. And we have also here the sex or even we have also the weight of the patient. Okay, we are using here the calculated GFR for the following. Number 1, to monitor, diagnose renal patients, mean to say those patients already na may kidney damage para ma-monitor natin ang kanilang, the status of their kidney functions. And second one, to monitor patient at high risk here of acquiring or having a renal disease or damage, that in the case of diabetic patient. Number 3, feasibility administration of nephrotoxic drugs. And the fourth one is for the eligibility of those for the reimbursement with the Medicare card. Okay, so what do you mean by number 4 here? So, yung mga insurance company, they would eventually predict here your glomerular filtration rate by having a computation lang. Okay, by just having the values of your blood creatinine lang plus the age, sex, and weight lang without collecting the 24 hours. Of course, here, if you're in the insurance company, hindi mo accept ang gusto mag-apply in your insurance company na may sakit na siya sa kidney. Tama ba? Kasi pag may sakit na siya, so every month na lang, ma-hospitalize ang patient. So, malulugi ang company natin. That's why dapat wala pang sakit ang patient. What are we referring here with the computed or calculated glomerular filtration rate? You could have here your Cockcroft gold formula, and another one, we have your modification of the diet in renal disease formula. So, we'll be discussing each of this one. Again, dalawa na to are just a calculated form of your glomerular filtration rate. Okay, we have here the Cockcroft gold formula. So, it's one of your calculated glomerular filtration rate. So, you could measure that one by just, wala na itong collection ng 24-hour urine. The formula for the Cockcroft gold formula, we have here 140 minus age of the patient. That's why we are needing the age. Multiply here by the weight of the patient in kilogram over 72. Multiply by the blood creatinine concentration expressed in mg per dl. So, kailangan lang natin ay weight, saka age, plus sex, plus eventually we have here the blood creatinine concentration. If the patient, for example, is female, whatever the result of this one, okay, you need to multiply by 0.85. Okay? If the patient would have here a normal na body weight. However, like for example, the patient would have here a problem with the weight, you need to identify, correct for the weight in the kilograms, you need to obtain here the adjusted body weight. Why? When are you going to correct here for adjusted or you're going to adjust here for the weight of the patients? Again, creatinine concentration is highly dependent on the muscle mass. Okay, so may mga tao kasi na malalaki sila but not because of their muscle mass, but rather because of their fats. Okay, so again, what we are measuring here is the muscle mass related to your creatinine and not on the fats. Kaya ang bigat nila because of their fats, not really on the muscle mass. That's why we are after all, since this one is only after of the muscle mass, that's why you need to make a necessary correction for that by having this adjusted body weight. How are you going to, so we have the formula for adjusted body weight. We have ideal body weight plus 0.3, okay, with multiply with the difference of your actual body weight or yung weight niya, okay, currently, minus the ideal body weight. But first, we need to obtain here the ideal body weight. Ideal body weight for the male is 50 kg, then mag-a-add ka ng 2.3 kg in every 1 inch higher than 60 inches. So, kung let's say, mga 62 inches ang height niya, Okay, mag-add ka ng 2.3 plus another 2.3. Basta in every 1 inch higher than 60 inches, then you need to add 2.3 kilogram with the 50 kilogram. Okay, so pag hindi siya more than 60 inches, then 50 kilogram lang. For the female, on the other hand, is 45.5 kilogram plus 2.3 kilogram for every inch higher than 60 inches. That become your ideal body weight. So, lalagay mo siya dito. Then, ititimbangin mo ang patient. That become the actual body weight. Then, ulit, kung anong result dito, ilalagay mo dito. That become here, ilalagay mo na siya dito. As a correction for your adjusted body weight because again, of mga for those na mga matatabang patient. Okay, then we have also another way of calculated GFR. We have here for creatinine clearance. We have here modification of the diet in the renal disease formula. So this one, medyo mahabang formula niya, but that one could be applicable here in the computer application. So parang i-just, parang lang, i-input mo lang lahat ng mga kailangan. What you are needing here for this type of calculated na glomerular filtration rate, we have here the plasma creatinine. So, blood lang ni patient. Plasma creatinine, blood albumin concentration, and urea or the blood urea nitrogen. Urea and blood urea nitrogen are just equivalent. Equal lang sila. Pareho lang. Okay, then what you are needing also the age, sex, and ethnicity of the patient. Wala itong adjustment for the weight. You don't need the weight of the patient. And you don't need also here the urine sample of the patient. Again, all this one are used for evaluation of your clearance, creatinine clearance. Okay, then we have also other substances here which has been utilized for evaluation of your glomerular filtration rate. So what we have discussed already, we have the urea, then we have also here your inulin, we have also creatinine. Another one, we have, number 4 na dapat pala to. We have here beta-2 microglobulin. Beta-2 microglobulin constitute here the light chain component of the human leukocyte antigen. And that one is, however, it's not reliable measure here of your glomerular filtration rate if the patient would have malignant disorders. Another one, your cystatin C, is another endogenous substance. This could be found here in all nucleated cells in our body. Lahat ng cells na may nucleus. So, WBC would always have the nucleus. You can find this cystatin C. Again, it's being used here also for evaluation of glomerular filtration rate. And this one is much sensitive measure actually of all. This is ideal parameter for evaluation of the GFR for babies, pediatric patients, for critically ill patient, and we have also elderly or mga adult age population. And lastly, we have also here your radioisotopes or the radionucleotides in the form of, you could have your iodine 125, you could also hear your other name for that is your iothalamate. So this one is being infused to the patient because this one is radionucleotides where it's being given the patient and try to monitor the radioactivity of that. So infuse mo lang siya, measure the radioactivity. We're able to visualize here 2 kidneys at the same time. Again, all this one are used for evaluation of your GFR. Okay, now we proceed with the test for the tubular reabsorption. The test for the tubular reabsorption, you call also that one as your concentration test. So this is the test here that would be considered here as a good indicator of the early renal disease. So pag early renal disease, your again glomerular filtration rate is not a good indicator for that because again, it could not assess the patient having an early renal disease. Again, your glomerular filtration rate could assess only the patients having already the disease. Pero pag early detection, hindi siya pwedeng gagamitin. Hindi siya ganun ka-sensitive as compared with your tubular reabsorption test. Okay, it's based on the principle here that the ultrafiltrate of our plasma, ultrafiltrate natin is 1 is 0.10. But are we expecting that ang entire urine natin is 1 is 0.10 pa din siya pag lumabas? Hindi, di ba? Because again, 1 is 0.10 na dito, remember na may mga reabsorption na nangyari dito, nangyari dito. Okay, may reabsorption ng water din dito. So we are not expecting that your urine output would have a specific gravity, the same with your ultrafiltrate. Now, the same dito na part, na 1 is to 10. And most likely, the specific gravity would be highly dependent on your water intake pa din. Remember din, pag sobrang dami ka ng water intake, nagiging diluted ang urine output natin. For the measurement of your amount of the solute dissolved in the urine, so we are having the specific gravity. Specific gravity is highly dependent on the number and the size of the solute. What do you mean by that? So, pag madaming mga solute na nakadissolve sa urine, expect to have a high specific gravity. Pag malalaki ang size ng mga solute natin, so again, mataas pa din ang specific gravity. Other way of expressing here the weight of your dissolved substances in your urine as your urine output will be in terms of the osmolarity. Osmolarity here is being expressed in terms of milliosmol per kilogram of your solvent. But how does it differ with a specific gravity? This one is highly dependent on the amount lang, not on the size. Okay, so kahit malalaki, what do you mean by that? So, like for example, itong solution, okay, so ito ay may mga ganito siya, versus dito na maliliit. Okay, so kung ito ay specific gravity, ang pagbabasihan natin, okay, so most likely, mabigat ito compare dito. On the other hand naman, kung osmolarity ang pagbabasihan natin, ito magiging mabigat compare dito. Again, your osmolarity is highly dependent on the amount, sa dami, not on the size. But your specific gravity is on the amount, the number of the solute dissolved plus the size. Yun ang pinagkaiba ng osmolarity natin. Okay, osmolarity here that's being utilized here for evaluation of your tubular reabsorption is being expressed primarily in terms of the colligative properties. Colligative properties again is highly dependent on the amount of the solute, not on the size. Okay, so if you try to add your certain amount of solute in your solution, that will change the colligative properties in such a way that it will increase the boiling point, it will also increase your osmotic pressure, it will decrease your freezing point, also decrease your vapor pressure. In the laboratory, ang ginagamit lang natin na osmometer will be the freezing point, and we'll also hear the vapor pressure osmometer. Okay, so most likely in the laboratory, routinely we are using here the two osmometry. We have here the freezing point, and we have also here the vapor pressure osmometry. The freezing point osmometer here is obtained here by cooling your sample until it becomes crystallizes para ma-reach na kanyang freezing point. So whatever the temperature needed to raise or to reach the freezing point, it becomes here the freezing point osmometer of your sample. So what you're doing here is just to compare your unknown sample with your standard para ma-obtain natin kanyang freezing point osmometer. Okay, so usually we are using the sodium chloride as your standard for that. Another one, we have here the vapor pressure osmometry, where we are expressing this one in terms of the dew point. The dew point here is temperature in which your sample try to vaporize and try to condense, maging liquid. So whatever the temperature para ma-reach yun, that become your vapor pressure. Okay, so ganun din, ang unknown substance mo, ang sample mo, kung gusto mo malaman kung anong kanyang vapor pressure, ilalagay mo siya sa filter paper, ilalagay mo siya sa chamber, and then try to seal that one and try to obtain here the temperature until may reach niya ang kanyang dew point temperature. Until na mag-produce siya ng liquid or try to condense, that become here the dew point temperature. We have here the technical consideration for two osmometer here, the vapor pressure, and we have also here the freezing point. The first one, we have lipemic sample. So if your sample here is turbid, lipemic is your lipemia is turbid na sample. It might be because of high concentration of the lipids. If your sample is lipemic or highly turbid na sample, it will affect both your freezing point and your vapor pressure osmometer. Lactic acid, on the other hand, would eventually also try to affect both of this one. That's why you need to preserve your specimen and try to analyze your specimen immediately. Another one, the presence of the volatile substance, like for example your alcohol in the form of the ethanol, will affect only your freezing point osmometer but not your vapor pressure osmometer.